Today we will start to learn another important statement called the if to control. We have learned the for loop. That means if you do the exact same thing, how can you use the for loop to just do that one by one? Okay. And for the if statement, that's more like if you have the different situation, how are you going to do that in different situation? So to understand the if statement, first we need to understand when it's true and when it's false before we actually understand how you're going to branch it into different places. So for the Boolean value, if you have the number, you need to know if you put a 2 equal sign, that's totally different from 1 equal sign. 2 equal sign means you need to do the comparison, and 1 equal sign, that means I will put the value inside of this variable. That's totally two different operations. And for the number, you have all these string, list, dictionary. I will talk about this one by one. So let's start with a number. So, and for understanding the Boolean value, right now I'm using the consoler. Lets you to see what's the difference. So I put a equal 10. So if I just put a 1 equal sign, you will see I put a one variable that has the name 10. Okay. And now if I put like a 2 equal sign, say a 2 equal sign 10, what's that mean? They say it's true. So you just make the judgment whether a is equal to 10 because the 10 is saved in a. So this statement is true. So, and another thing to say not equal, then it's the shift. So this sign, it's together with the number 1, okay, you put the shift and then press 1, so you have this special symbol. So when you have, say, a not equal 10, make the judgment, say, I have the statement, say, a is not equal to 10, but in reality, a is 10, okay? You cannot say 10 is not equal to 10. That's wrong. So when it's wrong, you will see they have the statement say it's false. Okay, so over here, that means this statement is not right. When you say a is not equal to 10, but in reality a is equal to 10, so that statement is wrong. Then if I say a equal to 15, at the current moment, it is 10. 10 is not equal to 15, okay? So this statement is wrong. So you get the false. So when you have the judgment a equal to 10, whether a equal to 10, you say it's wrong. Then same, a is not equal to 15. 10 is not equal to 15, so you get the value true. So you can do all these comparisons, and then you have say whether a is greater than 8, they say yes. Whether a is smaller than 8, they say no. Okay, and then you have whether a is greater or equal to 10. 10 is equal to 10, so it's true. Whether a is smaller or equal to 10, since 10 is equal to 10, so this one is also true. Okay, then say a greater or equal to 15, it's false. A smaller or equal to 15, that is true. So that's all things you can try to understand when I have judgment. When a equal to 10, how this can compare into whether I say it's yes or when they say it's wrong. So now I move to whether it's a text. Text is also very similar. So I initial value a equal to test. Okay. So now the value of a has been initialized to test. Then I will say whether a equal to test. I say it's true, and then I will have the statement whether a is not equal to 10. You say it's false, and then you say a whether a equal to another. Apparently, test is not equal to another. And what if I just capitalize a test like this one, or in in the A is all lowercase. What if I put the first one in the uppercase? You say it's wrong. So when you make the judgment, it's case sensitive. Okay, so for the string, whether it's equal or not equal, it's very easy to understand. But for the test, you actually can also have greater or smaller. So it could happen. But sometimes you need to understand what's the meaning of that. It's when you say whether A is greater than A, B, C, they say it's true. Why it's true? What are they going to do is actually have the comparison for the letter by letter. So T is actually after the letter A. Okay. So in that kind of case, if you look at this in the dictionary, suppose we have the dictionary, we will look at A first and then look at the test in the following pages. Okay, if they have the words A, B, C, and test, apparently A, B, C will be in the front and test will be something later on. So you can consider like the page number where they are. So, and the A test will be in the page number probably at the very end, it's like 1000. And ABC probably is in the very beginning, like 8 or some page number. So you can see the page number of A is greater than the page number of ABC. So okay, that's true. And then when I saw the opposite sign say A smaller than that, apparently the page number of the test should be way after that. So then you can see they say, okay, this page number should be not smaller than that page number of ABC. So the same thing if you look at it, whether A is greater than XYZ. Apparently XYZ would be even later, okay, than test. So in that case, it's a false. Then when you reverse it, it's true. So that's all the same. What if the first letter is the same? Then I will compare in the second letter. When the second letter is the same, I will compare the third letter. When the third letter is the same, I will compare the last one. So as you can see, this one, TSZ, should be at later pages. So if you look at this one, you will believe this statement should be wrong. Okay, it's a TES, it's the same, but the Z is after the T, so it should be in later position. So you can see they say it's wrong, and the opposite side it's true. Okay, so that's for this one. Then for the list, now I change to a list number. Say A is a list 1, 2, 3. So the statement, this one, you will say whether this is equal to this one. True. Okay. Apparently that's true. Then this one, if you look at this, from what we learned, you should make the judgment. It's false. Okay. It should be equal to this one. But keep that in mind. A list has a position. So when you have this one, it's first is 1, 2, 3. So comparing to the list 3, 2, 1, although it contains exact same element, but their position is different, and they will give you the false. They should have the exact matching. If they do not have the exact matching, it's just like the text. Even you have upper and the lower case, still they will consider as different things. So still the same equal, not equal, easy to understand, but the greater and smaller, you have to have the same understanding as a string. So they will do the comparison of the first one to see whether the first element is greater than that. If it's greater than that, then I already return say it's greater. But if it's smaller than that, it should be smaller. So from the comparison of this one, as you can see, it have 1, 2, 3 here. The first element 1 is actually smaller than the first element 2. So you will see it's a false. Okay. And if you have the comparison like this one, the first element 1 is actually greater than the first element of 0, so you will say that's true. So that's the one you can have. So you have greater and smaller. It's the same as you try to understand as a text over here. So start with the first element. If they can make the position, then they give you the results. If they cannot make which one is bigger or smaller, they're comparing the second one or the third one. So over here, if I say A equal to, if it's 1, then they cannot make any judgment. Then I will put a 3 here. They say it's a false. But another thing I'm curious is, what if I put a text here? I don't know how they're gonna make the judgment. Okay, looks like they will not be. So when they try to do the comparison, it's very important, like the element inside in the corresponding position inside of the list, you have to be the same type. If they are not in the same type, they actually have something wrong here. Okay, but besides all of this one, they have some additional keywords there. It's a 1 in A. That's also a statement. Say whether they have the element 1 in A, they say it's true because A contains 1, 2, 3. And then if I use a text 1 in A, they say it's false. So because we don't really have the text 1 here, we only have the number 1 here. And if say 4 in A, you get it false. I'm curious for the string, like let's say A equal to test, whether I can check some letter to say T in A. Oh, okay. Looks like they can have one element to have this one. I will see TE. Oh, so if you want to know whether they have some substring in this text, let me see. They have the ES. Okay, they have the true. So if you want to see whether a string really contains a substring, then you can also use the keywords in over here. So that's just for the string. So string also have the in, but apparently text do not make any sense over here. Okay, so what if for the dictionary data, so they have a different data type, but usually we will just have the comparison between, how to say, usually we just have the comparison between number and text. In very rare case, we will have the comparison in the list of the dictionary data, but you still can do the comparison. So that's why I'm have the introduction here. So let's say I have the dictionary data. They have the 3 key value pair, name, age, and class. So when I say whether A equal to this one, they have the exact matching. Apparently that's true. Okay. But what if I make the change? Say the name here, but the age value has been changed to 8. And then let you see over here, apparently when the value here is changed, they just have the false. Then what if I have the key instead of say age, I say age 1. And when you do the comparison, they still have the false. So when you need to have the equal sign, you need key value pair are all exactly the same. However, what if I change the sequence? Instead of have the name, age, and the class, I can put the age, and then the class, and then the name. Look like this one. And if you look at this, you'll see they give you the true information, okay? As long as the key value pair are exactly the same, they don't really care about the sequence. So dictionary data do not care about the sequence. As long as the key value pair is the same, but for the list, they do care about the sequence, okay? Because when in the dictionary data, they are using the key to have the reference to the value, but in the list, they are using the position to have the reference to the value. Okay, so dictionary data don't care about the sequence, but the list do care about it. And then say, okay, not equal to, so you can make the judgment. Apparently, they have the exact matching, and say when they're not equal to, they have the false, and this has make the change, and then you see, okay, whether that's true. Okay, because they are not. So And when you use, they also can be used in, but when you say whether the name is in A, they give you true. Say, I do have the key over here in the dictionary for you to have the reference. But when you say whether I have the Zara here in A, they give you the false information. Okay, they don't really have the key named Zara. It's just they have some people named as Zara. So if you want to know whether their name is Zara, what you need to make the statement is you have to use dictionary data A, have the brackets name to say in the name components whether their value is equal to Zara. And you can see here that give you the true value. Okay, so when you use the in the dictionary data, you need to keep that in mind. They just have the reference of the key, not the value after the semicolon. So that's a lot of memorization, and I believe you probably will not be able to really remember this. I don't either. It's only when I need to use it, I will search it. It's just like the word, like in English, they say they have actually have a million words there. Do you really remember all the million words? I don't believe it. You probably at most can remember like 10,000 words. That's enough. And if that's really something new, it's like in the chemical or biology or in some area you will never have the exposure. You don't have the expertise to. You don't even bother to remember it. And if they come to you, you just look at the dictionary, search online to figure out the meaning of that. Same thing here. Python has so many things you will not be able to really remember everything. All you need to do is actually needs to learn the fundamental, and then when something weird comes in, you probably need to go online and search for that. So after we understand how these do the statement, then we can move to how it's working. So for the if statement, I will ask you to look at this one and see how this is gonna look like, and also help you to understand when it's within the dent and outside of it, how to do the interpretation. So in the first, I will say A is equal to 2. Okay. Then I have a statement. Instead of the for and the semicolon, I have the if statement. Say if A is greater than 0, okay? If this is true, I will do the statement within, okay? Within this if statement, as long as they have the indent here, that means it's within this. But look like this one is outside of it. It's not under this control anymore, okay? Then when you go here, you have another if statement. Say, if it's true, I will do this. If not, I will ignore any content inside. And then when you jump outside of this one, you will have another thing. So try to understand how this is going to be working. So I will give you run it first. So when is A equal to 2, when you go to this statement, say A greater than 0, 2 is greater than 0, it's true. So here you can see it's a positive number has been printed. If the second line executed in the first condition, that also will be printed. So as long as the statement is true, anything within this if statement will be stated. And when the outside of this one, because you go outside of sequence, and they say it will be executed anyway. So this line will be printed. And then when you jump over here, say A is smaller than 0. So 2 is not smaller than 0. So you can see it's a negative number. I don't really print that. The second line in the second condition also I didn't print it. But when I jump out of this line statement, say that's another command will be executed anyway. So this one will be executed, right? So now let's say, okay, I will change this to -1. And I have the feeling how this is going to do. So when it's -1, you can see this statement is wrong. I will not print anything inside here, but this will be executed. And then -1 is smaller than 0, so I think this will be printed, and this one is also will be executed anyway, and see whether this gonna match our expectation. And then let's just run. It will be executed anyway. It's a negative number. It's a second line executed in the second condition, and that's another command will be executed anyway, right? So what if I put the 0 here? So make think and see how this gonna match your expectation. Will 0 greater than 0? No, it's equal. It's not greater. So nothing will be printed here. But this one, because they just go through the sequence, so this will be printed. And then whether 0 is smaller than 0. 0 is not smaller than this one. So nothing will be printed here. But when you go to sequence, this will be executed. So you will see when a is equal to 0, you only have these two lines, but nothing inside of the statement. And when we run this one, you'll see I will only execute these two. Okay, so this one is just help you to understand when you change this into different condition, what's the logic related to the if statement. And then let's just try to see another one. If else. So the statement for this one is almost the same. So they will make the judgment, say whether it's greater than 0. If it is greater than that, I will print the condition over here. But you have another keyword else. But keep that when you write if or else, you need to have the semicolon here. Okay. So if a greater than 0, semicolon, you print this condition. Else, I will print this condition. And then you have the last one that will be printed anyway. So let's say when a is equal to 2, apparently a is greater than 0, so I will print this block. Since I printed this block, let's say something otherwise, but it's not otherwise. There is nothing otherwise related. So I will just go into this block. I will not do anything like here. And you can see I will print this line and then the last one. It's a positive number, it's second line of the if condition, it will be executed anyway. Okay, so now what if I change this to 0? When it's 0, you can see 0 is not greater than 0. So this condition is wrong. So if it's not this condition, I will go into another something else. I follow into another category. So another category related to this one is a smaller or equal to 1. So it's actually right. So I will say it's a non-positive number is second line in the else condition. It will be executed anyway. And you can see that's how they're going to do. And what if I'm using the -1? Well, when it's a -1, apparently it's not greater than 0. This statement is false. Then I will go into another block. So I still go to this block, but this one will be executed anyway. So you can see it's a non-positive number, second line, and it will be executed anyway. Okay, so let's just help you to understand the if statement. And now the if statement is actually not really that hard for you to think about. Okay, and but something else. So you will have another keywords called the else if. Something called this one. Okay, and I don't bother to teach you here. It's very similar. You can just search online and try to understand the syntax of this one. As long as you can understand if and else, something like this one should be for the situation. If you have not just two conditions, you probably have 3 different comparisons or 4 different comparisons. But you can always have another way, not using this one. You can just have if else and is nested with another if else. It's really up to you. So over here, I just ignore this part. If you are interested, you can do that by your own. Over here, I would like you to actually, like, why should I learn this? So before we move to the challenging question, try to get the sum of the salary for the people in the New Jersey. Let's just try to play this game. So this computational type of thing, it's actually, you will see the same idea to a lot of things in your real life, okay? And even you have the how do you say, play the game or do the rest of the things to how to organize. So over here you have the block of the code. They just teach you three fundamental components. Sequence, it's like how you're gonna do the first step, second step, third step. Or you have the for loop, it's like if you do the same thing again and again. And then when you have the if statement to see if I have the different condition, what should I do in different scenario. So over here, you can see you have the Angry Birds. So the things you have to see is moving your bird to meet the pig, okay, to win. So over here, when it's run, they say, okay, I will move forward. If you click run, you can see the birds come here, and then stop, okay. So you are not there yet. So what you're gonna see is you have to do the reset and say, okay, it looks like I need to have another move forward. And then when I click run, I move this one and move that one, I can see, okay, cool, I can start to meet the pig. Okay, let's just move. This is the first thing, you just have the sequence. But over here, you can see you move forward. Apparently, when you click run here, it's just jump one step, but you still have two additional here, right? So what you're gonna do is you have to move forward twice, and then try to play with that. Okay. So this is a training, even it's a game, but that's the things to train you how to have this computational thinking. And then they start to move a little bit hardware. So you move here, you can one forward, two forward here, right? But if you have another forward three, you are moving the breaking the wall. So if you're doing things that look like this one, jump, jump, and hitting the wall, you're not achieving your goal, so you fail. So what are you gonna do? You can see you have a different command. So you can see when you're moving here, you need to turn right in this direction and move. Let's say I move something wrong. I actually move two steps and make the left turn. You can see I will move up because right now I'm facing here and anti-clockwise. Then over here I will go to the TNT and we'll see I have the explosion here. I move, make the turn. You can see explode and I fail. So you can see, oh, I actually doing something wrong. I need to, okay, over here, I need to change this to right and then do that again. That's how you meet the pig. Okay. So that's a lot of things you can play to see and see what you need to plan the routing for you to have. You cannot go this route because that's a TNT here. So you have to go this, this, and this. So that needs you to make the turn and make it more forward, but that's the thing I would like you to have it try on your own. So now I move to the section 6. But that's all a fun game. You can just play one by one. So you can see here, as I just, before I give you the for loop, you can manually just do the exact same thing, write the code 5 times. So all you can do is, you can see I move 1, 2, 3, 4, 5. I can have this one, okay? move forward 5 times. That's what I'm gonna do. And when I run this one, you can see you can meet the pig, but let's say you are supposed to have 3 blocks, but you are using 6. You have using too much. So I will just let's see how okay, move. Okay. So you have something coming here, and then it's like the for loop. You just do the same thing 3 times. When you have the 5 times, 1, 2, 3, 4, 5. Okay, so now you can see your code is more concise. If you do exact the same thing 5 times, why bother not using the for loop? Because if you just write in the same code 5 times, it is okay, but when you try to write in the same code 100, 1000, a million times, that's apparently too like a doesn't make any sense, right? So over here, you can see the bird is actually facing this direction. So what you're gonna do is you need to facing the downward south part, and then go this direction. So what you need to do is you need to turn right, facing here, and then move forward 5 times. So sometimes you need to do some pre-processing before you can just do the repeating. So think about how we can add the salary information. In our previous example, is you need to load the information from the text data and read that as a list. And then inside each element inside of this entire list, I will try to process one by one, right? So reading the file and then prepare this list is something before the for loop. Okay, it's before the for loop. I need to do the preparation before I can do the repeating. So that's the things you can see. That's a combination. You don't really have the things like I only have the sequence. Oh, I don't really have the things. I only have the loop. It's a combination. It's just whatever when it's needed. So over here you can see they make it a turn and then move forward. Do you have this one? Okay, and that's all the game. You can just try. Let's see. I don't know whether they can show you if you don't know the answer. Let's see. Okay, I do this one. I move forward. I make it run. And I fail. Let me see like how they can give you the answer. Not quite. Use start over. They have no answer for here. Okay, so looks weird. I think they should give you the answer. Let's see. They only give you the hint. Okay, anyway, to me this is not really something. I believe as long as you are adult, you should be able to do that. You can see the route you have to do is go to this direction, then you make the turn and then go this direction. So over here, it's you are repeating moving forward 5 times to reach here, right? And then the next is you need to make the turn. When you're facing make the turn, you need to still move forward 5 times towards that direction. That should be the things you're gonna do. And you can do that by your own. I will just directly give you the answer. Oh, it's they actually do the 4 times. Okay, 1, 2, 3, 4. Okay, it's not 5. It actually should be 4 times. Okay. And sometimes when you're writing the code, they have the bug. That's how you're gonna make the change. Okay, and then 1, 2, 3, 4, 5. Okay, then I come to see the pig, and then in the remaining, I will just give you the answer. I don't even bother to do that. They say they start with 3 pattern. So over here, what kind of pattern you see? You will see you need to go this direction, and this direction. What kind of things you will generalize repeat 3 times? You will see you move forward 2 and make the turn. If I don't do that, I just write in the code like here. I move forward, and then I make a right turn, right? And then when here I move forward, I need to make another right turn. Facing here. So you can see now this move forward, make the right turn, it's repeated. Okay? So that's the block you actually repeating from here. So you just need to see you have the 3 general of these patterns. So that's what you supposed to have. Move forward, make it right, move forward, right, move forward. You don't need to have the right, but you already reached that. That's the way how you gonna see the generalization. Okay. And then have the last one is sometimes you don't really need to count how many times you have. You just until some goal achieved, you just keep moving forward. So this kind of iteration is just like the for loop is like a for item inside of the list. What until you read everything in the list, I'm done. I don't care how many. It's as long as you have the element in the list, right? So the same thing is like starting from the number 0 all the way to the length of the list. It's the same thing. After you finish everything, I stop. Otherwise, you just keep doing that. So over here, go this, and go here. So move forward, and make the left turn. And you can see when you play the game, this is almost the same logic when you write in the code. Okay, so here you can see you have this Z. Um, you have this pattern, then you have this pattern, you have this pattern, you have this pattern, you have this pattern. It's the same thing, like moving this pattern. Okay, it's moving forward, then makes a left turn, and then moving forward, then just moving forward, makes the left turn, moving forward, and then make a right turn, and then just keep moving forward. I don't need to, so moving forward, left turn, moving forward, right turn, you keep doing that. Okay, so over here you can see if you spot a pattern and repeat it, and apparently you should not go this direction. You should down here, 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 here. It's the same thing. I don't bother to to finish that. You can use this as exercise. And over here, so now you can see the start have something extra. They have the if statement. Say I keep moving forward. But over here it's like if I have the path to, I will just keep moving forward. But when the path have the path to the left, when I go over here, I don't have the path to the left. Okay, when I go over here, I do have the path to the left. What should I do? So if I just keep move forward, let's see. I sense there's no path over there. I make the sense they do, but I keep moving forward, and it looks like I'm blocked. So what's the right thing? You actually need to make the turn, right? So it's only when you have the path to the left, I will make the turn. If I don't, I just keep moving forward. So you can see, you have the zombie here. When they have the left, then I will make the turn. They don't. I sense they don't. I sense they don't. I keep moving forward. I will not do anything inside here. And that's a combination for you to see how you gonna make all these together. So the same thing is like you repeating. You keep moving as long as you can have the path to the right. You make the right turn. Otherwise, you keep moving forward. It's the same logic of the previous one. So if they have the path to the right, I will make a right turn. Okay, the same logic with the previous one. That's the control how you can move towards your goal. Okay. Then for the 16, same thing. Move forward. Okay, if you have the path to the left, I will make the left turn. That since I just keep moving. So you can see even it's some complicated paths as long as you can see the internal logic of this one. That's how you generalize as a code to achieve your target. This one is the same. I don't bother to do. Okay. Let's see whether you have anything like special. Okay, so over here, you can see now they keep repeating and move forward. That's the sense. But the condition has been changed. They say if they have the path ahead, if they still have the path ahead, I will, or you have the to left or to right. But you can, in the previous one, if you say I have the pattern, it's if I have the path to the left, I will make the left turn. Okay. Else I will just moving forward. So from here you can see I can successfully make this turn. I can successfully make this turn. But when I come here, I will come across this direction. And you can see that's how you're gonna do. I have the path over here. I will come to this direction. And I will just fall into the water. Apparently that's not what I have. And then let's see whether you have anything else. So if I have the path ahead, I will just keep moving. But if I don't have the path moving forward, then I will make the left turn. So when you go over here, because you still have the path for moving forward, you will keep moving. And that's the logic how you're going to achieve your goal. So that's require you to summarize your path in more concise pattern to reach your goal. So that's the type of thing require you to have the logic thinking and try to have the summarize to try to avoid the pitfall. Okay, so that's the same thing over here. You need to use pass ahead of time instead of like if you have the left turn. And then for the last one, if I have the so now here they change something else, but I would like to see they have very curly pattern. Sometimes they turn left, sometimes they turn right, but that's also require you to do some summarization. They already have fixed, okay? If they have the past ahead of time, what you should do? Move forward. If you have the so in that here, but if they don't have any past ahead of time, then we'll see whether they have the path to the left, right? If I have another path, I will turn right. If they don't, I should turn left because there's no path ahead of time. They either should be in the left turn or the right turn. So that's the things you can have. If they have the right, I will turn right. Otherwise, I will turn left. That's the thing summarize what you should go through this challenge. So you can see that's how they make the sense and make the decision when to make the left or make the right and how they're gonna go over there, how to make the turn. Okay, so once you finish this game, then we will just go back here to the challenging question. I will not give you the answer, but I will try to let you see whether you would be able to finish that. Okay? Try to think about how you're going to do this manually and before you translate into the code. Keep that in mind. Computer cannot do anything magic. They just do whatever is in your mind. If you have no idea how to do that in your mind, computer will not automatically figure that out for you. Okay? So how can I get the sum or the salary in the New Jersey people in this like employee data? It's CSV data. So how I read this, get salary information. I also need to get the state information, and I need to make the judgment. It's in New Jersey, I will do that. If it's not, I will not do it. So that's something more like how to computational thinking I will talk about in the later on. So it's like when you try to tackle some slightly complicated problem, how are you gonna process this like one by one? Okay.